In the last class, as I discussed about what is the photoelectric effect. It is the phenomena in which electrons are liberated from the surface of certain metals when the light of suitable wavelength incident on it. So here some important terminology you have to familiar that when a suitable wavelength incident on certain material. What do you mean that? Suitable means, so for particular light radiation you have to use for particular metals. Say for example, say all alkali metals, they are photosensitive for visible light. So alkali metals means, as you are already familiar, that sodium, potassium, rubidium, cesium. Among these you take that any photosensitive metal over which if you incident that visible light radiation, as a result photoelectrons are going to liberate from the surface of the metal. Such metals we are calling that photosensitive metals. So that means that alkali metals, they are photosensitive for the visible light, whereas zinc, cadmium, manganese, they are photosensitive for the UV rays. As you know that UV rays means ultraviolet radiation. When the ultraviolet radiation incident on the zinc, cadmium, manganese, these metals, they are photosensitive. I mean that zinc will go into photosensitive only when you are incident the UV rays. So if you over the zinc, if you incident visible light radiation, it won't emit any photosensitive, it won't emit any photoelectrons. I mean that it won't behave as a photosensitive metal. So in order to behave as a photosensitive metal, over the zinc you have to incident only what UV rays. So in order to act as a photosensitive metal, so if you incident that visible light over the alkali metals, I mean that totally different substance or different metals, they are photosensitive for different wavelength of light radiation. Say, as you know that alkali metals, they are photosensitive for the visible light, whereas the zinc, cadmium, manganese, they are photosensitive for the UV radiations, right? So when say for example, see this is an as you know that I don't want to explain it. So this is what cathode. This is a photosensitive metal that. Over this photosensitive metal, say that visible light radiation incident on it. As a result, so this visible light brings that photons. These photons, they will carry a definite amount of energy. So when these electrons, when they are going to collide with the free electrons of the cathode, so while colliding that, photons complete energy will going to absorb by the electron. As a result, the energy of the photoelectron is sufficient to come out from the surface of the metal. So therefore, these electrons, they are come out from the surface of the cathode. So after coming from the surface of the cathode, they are going to assemble very close to the cathode. Cathode will going to act as an rich source of electron, or you can say that it is an emitter. Since it is going to liberate, it is going to emit, so therefore it is going to emit electron. So therefore it is called as the emitter. These electrons, they are going to assemble in front of the cathode. In order to push these electrons toward the anode, there should be positive potential across the anode. So that means that whenever a light of suitable wavelength incident on certain metals, photoelectron will going to liberate from the surface of the metal, photoelectron will going to eject from the surface of the metal. This phenomena, which is known as the photoelectric effect. Now so emitted electrons so emitted electron, they are called as the photoelectrons. If these electrons, if you passed through the external wire, which constitutes the photoelectric current. So now we have seen that what is the photoelectric effect and what are the photoelectrons, is it? How to generate the photoelectric current. When these photoelectrons, after passing through the external circuit, which constitutes the electric current, that electric current, now that photoelectric current, that can be measured by using the micrometer. Since the magnitude of the photoelectric current is very small, so therefore we are using that micrometer. Now, so in this background, so actually this was accidentally discovered by the Hertz, is it? Later on, that Einstein explained the photoelectric effect. Let us see what is the experimental setup for the photoelectric effect. We would like to discuss about the schematic diagram of the photoelectric effect. So as you know that, so this is in a glass envelope, is it? So this glass envelope consists of two electrodes, one C stand for the cathode or K stand for the cathode and A stand for the anode. These are the two electrodes. One cathode is going to act as an emitter. Since it emits the electron, therefore it is called as the emitter. So emitted electron, they will move toward the anode. So this anode is going to collect all the emitted electron. Therefore, anode is also called as the collector. It collects the photoelectron. Therefore, it is called as the collector. So now, for this glass envelope, it has a side 2, is it? Side 2 enclosed with the quartz window. Here, this is a quartz window which is covered by the is closed by the quartz window. You see, it is closed by the quartz window. You see that this is a source of light radiation. See, this is the light radiation it is moving. After passing through the quartz window, what is the role of the quartz window? Quartz window, it allows only particular wavelength light radiations. Is it? So particular wavelength light radiations. So this is a source of light radiations. This is a source. Okay. So this is a light radiation. So this light radiation consists of stream of photons. That photons, they are moving on a particular. Photons are moving on track. Is it? Each photon having a definite amount of energy. Is it? So when the photon brings a definite amount of energy, when this photon, when incident on the cathode, it is going to penetrate inside the cathode. Is it? When it is penetrating inside the cathode, it is going to collide. It is going to strike with the free electrons of the cathode. Is it? As a result, that electron will go to, that photon will go to absorbed by the electrons. As a result, the energy of the electron will go to increases. So therefore, if the energy of the photoelectron is sufficient to come out from the surface of or it is more than the work function of the metal, then what happens that those electrons are going to come out from the surface of the metal. Those electrons, they are assembled at in front of the cathode. Now, as I said, what is the role of this quartz? Quartz, it acts as a filter. It allows only monochromatic light radiation. That particular wavelength light radiation is going to allows, whereas the other light radiation is going to absorb. So that's why it is called as the filter, or otherwise filter. It is nothing but the quartz. Okay. So as you know that this is a source of light radiation. This is a quartz window. As I said, it is a glass envelope which consists of two electrodes. One is called as the cathode. Cathode is sometimes it is also called as the emitter. Since it emits the electron, therefore it is called as the emitter. So emitted electron will go to collected by the collector. So anode is also called as the collector. So it has a side tube. So side tube is enclosed with the quartz window. Quartz window acts as a filter. Filter, it allows only particular light radiation, whereas it absorbs the other than the particular light radiation or particular wavelength radiations. Is it? So now what happens that? So to this circuit, so you see that you have to connect a battery. Is it? So this is a high tension battery. Positive terminal high tension battery, it is going to connect for the anode, where the negative terminal battery should be connected for the cathode. What happened that this is COM, I mean that commutator. The role of the commutator to change the direction of the current or polarity of the these electrodes. You see, so you can say that polarity of this electrode. This is what, as you know that cathode and anode polarity you can change by changing the commutator, right? This is a function of the commutator to change the polarity of the anode and cathode. Whereas this is the micrometer which measures the current. This is the voltmeter which is connected to the parallel to the this battery. So which measure the voltage. So whatever the voltage you are applied, whatever the voltage you are generated by using this high tension battery. As you know that high tension battery, this is a negative, positive terminal. This is a plug key, is it? With the help of this plug key, you can make switch on and off. So this is the rheostat. So with the help of rheostat, you can change the current in the circuit, or I mean that you can change the voltage in the circuit, right? So this is what the complete experimental, that experimental setup of photoelectric effect. Is it? So as I discussed that, the basic thing is that there are a few parts of the experimental setup. One is that a glass envelope. It has a side tube covered with the quartz window. It has got two electrodes. Is it? One will go to act as a cathode, another will go to act as anode. Cathode is a rich source of electron, therefore it is called as the emitter. Since it emits the electron, so therefore it is called as the emitter. So emitted electron, they will go to move towards the anode. Anode will go to sometime it is also called as the collector, because it is going to collect the electron, therefore it is called as the collector. So these collected electron, after passing through the external circuit, as a result it is going to constitute the photoelectric current. Photoelectric current can be recorded by using the this ammeter. Since the current is very meager, very little, therefore we are using the microammeter. Is it? So now this is a commutator. By using the commutator, we can change the direction of polarity of the anode and cathode. Whereas this is the voltmeter. By using the voltmeter, so how much potential difference you are applied for the cathode and anode, we can say we can measure it. So this is the plug key. By using plug key, we can make on or off of the circuit. This is the rheostat. The function of the rheostat, as I said, that to vary the current in the circuit or to vary the voltage. Is it? It will act as a voltage divider. So let us see. First of all, these are the things we will discuss, that what is the working principle and all these things, how it is going to act, as should I discuss with it. Here in this experimental setup, basically you have to study that three important things. First is that relation between photoelectric current and intensity of incident radiation. Is it? So how the photoelectric current depends on the intensity of incident radiation. See, the source of light radiation, as you change the distance between that this side glass window and the quartz window and source, so what happens that the intensity is going to change. By changing the distance between quartz window and source, we can vary the intensity of light radiation. So on changing the intensity of light radiation, what happens on the strength of photoelectric current? That means that you are studying the relation between strength of photoelectric current and intensity of incident radiation. So from this graph, you plot a graph of intensity of incident radiation. So I not represent this. Say that intensity which is represented by I not represent the intensity of radiation versus IP. IP stands for the strength of photoelectric current. See, you see that as you are go on, this is the origin. As you say that as the intensity you are go on increasing, that corresponding to that strength of photoelectric current is also increasing. Say for example, when the intensity is 0, photoelectric current is 0. Say that when the intensity of radiation, say it is 20, so corresponding to that strength of photoelectric current, it is 20 microampere. So like this, if you go on increasing the intensity of light radiation, corresponding to that strength of photoelectric current is also increases. So that means that from this graph, what we concluded that strength of photoelectric current is directly proportional to the intensity of incident radiation. So the question is that intensity of incident radiation depends on what? Is it? So intensity of radiation means in every second how many number of electrons will going to come out from the surface of the metal. As the more number of electrons comes from the surface of the metal, as a result strength of photoelectric current is also increases. I mean that the number of ejecting electron magnitude goes on increases, corresponding to that strength of photoelectric current is also increases. So that means that as the number of photoelectrons increases, corresponding to that intensity of intensity of radiation is also increases, corresponding to that photoelectric current is increases. So from this what we concluded that the photoelectric current is directly proportional to the intensity of incident radiation. Is it? As the intensity of incident radiation decreases, the number of photoelectron ejecting from the surface of the metal decreases. As a result, the strength of photoelectric current decreases. So therefore we concluded that IP is directly proportional to the intensity of incident radiation. This is the first experimental result. Now second result is that photoelectric effect is instantaneous one. So instantaneous ones, what we mean that instantaneous, very quick one. As soon as the light radiation incident on this cathode, the time lag between the incident of incident radiation and emission or liberation of photoelectron is 10 to the power minus 9 seconds. So that means that in the nanosecond this event is going to take place. When the light radiation incident on the cathode and emission of electron, the time gap between the incident and emission of photoelectron, it is about 10 to the power minus 9 seconds. Therefore, it is in a nanosecond it is taking place. So therefore, this process is instantaneous one. When a light of suitable wavelength incident on any metal surface, in a few seconds, in a nanoseconds, the photoelectrons start to liberate from the surface of the metal, provided that the incident light radiation above the threshold frequency. The frequency of the incident radiation above the threshold frequency. Threshold frequency means it is the minimum frequency of the incident radiation, below which there is no photo emission, above which you will observe the photo emission. So that means that, this figure shows that we have to imagine that incident light radiation frequency is above the threshold frequency. Thereafter that, as you are on increasing the increasing the intensity of incident radiation, corresponding to that photoelectric current will go to increases. So therefore we will get a graph, a straight line which is passing through the origin. So it indicates that, it represents that the photoelectric current is directly proportional to the intensity of incident radiation above the threshold frequency. This is the second conclusion. This is the second experimental result. Let us see. Would like to discuss about the third experimental result about that is where this graph shows the relation between kinetic energy and frequency of incident radiation. Say for example, as I said that certain metal. So they are certain metal, all alkali metal, they are photosensitive for the visible light. whereas zinc, cadmium, manganese, this is the photosensitive for the what? Ultra UV light radiation. So here we are considered for the, this is, imagine that sodium, this is what? Potassium. For this you see that here in this graph we are plotting relation between Ke represent the kinetic energy of the photoelectron. When the photoelectrons come out from the surface of the metal, these electrons, some electron will going to move with a little velocity, some will going to move with the high velocity. So as the velocity changes, kinetic energy of the photoelectron is also changes, is it? So what is the relation between kinetic energy of photoelectron and frequency of incident radiation? If I increase the frequency of incident radiation, what happens on the kinetic energy of the photoelectron? Whether the kinetic energy or whether the velocity of the photoelectron increases or decreases, all these things we are going to study in this relation, that is kinetic energy versus frequency of incident radiation. So if you take that frequency of incident radiation along the x-axis, kinetic energy, if you take along the y-axis, say for example sodium metal, you have taken that, this cathode which is made up of sodium metal, now so source of light, this is a source of light, this is what, this is an alkali metal. So imagine that this is what visible light were incident on this cathode. As a result, this cathode will go to emit the photoelectron. These photoelectron, all photoelectrons come out from the surface of the metal. They may not possess the same velocity. Some electron possess more velocity, some electron possess less velocity. Is it? The velocity of electron, that how it depends on the frequency of the incident radiation. So here once again, what you have to do, that frequency and potential difference you have to fix. And that frequency of incident, this intensity of incident radiation and potential difference between cathode and anode you have to fix. Then only you have to change the frequency of incident radiation. If you want changing the frequency of incident radiation, what happens on the kinetic energy of the photoelectron? See, you see that actually in this graph IP versus INR, that is a graph will start from the straight line passing to the origin, whereas in this case that is not happening. Why it is not happening? You see that. So this is this graph what interpreted that there is an existence of threshold frequency. So how it is explained that? So if you say for example sodium example. So sodium metal, imagine that threshold frequency of naught, which is nothing but the 2 Hz. So on x-axis we have taken that this is the